In the last few decades, China has undergone an extraordinary transformation, becoming the world's fastest builder. From bridges and skyscrapers to entire cities and tunnels, China's construction feats are completed in record time. What was once an arduous task of manual labor and slow, traditional methods has now been redefined by powerful machines designed for precision and speed. These machines are not just engineering marvels. They are reshaping the geopolitical landscape and redefining global construction standards. In this context, China's aggressive approach to engineering is not just about increasing efficiency. It's about gaining a competitive edge in the global arena. As nations around the world watch in awe, China's building capabilities, enhanced by cutting-edge machinery, are setting a new benchmark in the construction industry. These developments signal a pivotal shift in how infrastructure is created and who controls the future of construction technology. The Bridge Beast, SLJ 932, a giant in steel. One of the most iconic examples of China's engineering prowess is the SLJ 932, nicknamed the Iron Monster. Weighing in at a colossal 580 tons, this self-driving machine has revolutionized the traditional process of bridge construction, transforming an industry long dependent on cranes, scaffolding, and months of labor-intensive work. In the past, building massive bridges required the meticulous coordination of large crews and complex machinery, often spanning years to complete. Projects such as the Beijing-Zhuhai Expressway, vital for the nation's infrastructure, could take several years due to the need for traditional construction methods. However, the advent of the SLJ 932 has changed the entire timeline of such projects. This extraordinary machine bypasses the need for cranes and scaffolding entirely, instead using precision engineering to place massive bridge segments with pinpoint accuracy. The SLJ 932's ability to construct bridges with such efficiency has led to a dramatic reduction in the time required to finish major infrastructure projects, with completion times now halved compared to traditional methods. It works by positioning prefabricated bridge segments while moving seamlessly along a rail system, offering a level of automation that ensures both speed and accuracy. The machine's design eliminates human error, guaranteeing higher precision and reducing the risk of accidents, a critical factor in ensuring both safety and quality in construction. This technological marvel is also a cost-saving machine. Not only does it save valuable time, but it also minimizes labor costs, reducing the number of workers required on site. The SLJ 932 has thus become a symbol of how China's infrastructure development is merging cutting-edge innovation with practical efficiency. It serves as an example of how advanced machinery can contribute to sustainability by streamlining processes and reducing resource waste. Beyond its immediate impact on China's infrastructure, the SLJ 932 is poised to influence bridge building practices on a global scale. As the machine continues to evolve and gain traction in both domestic and international markets, it sets a new standard for bridge construction worldwide. The ability to quickly and safely complete monumental projects with precision has the potential to redefine the global infrastructure landscape. China's engineering and innovation in construction machinery, exemplified by the SLJ 932, signals a future where advanced technology will continue to shape the way we build the world around us. Skyscrapers in days, China's modular construction revolution. In another stunning feat, China has achieved what many thought impossible, building a 57-story skyscraper in just 19 home days. This remarkable achievement was made possible through the use of modular construction, a groundbreaking method in which prefabricated building modules are produced in factories and then transported to the construction site, where they are stacked and assembled like pieces of a complex puzzle. This technique, which has transformed the way cities are built, is championed by companies like the Broad Group, who have pioneered its widespread use. The process allows for the rapid construction of high-rise buildings that would traditionally take months or even years to complete. By shifting much of the work off-site and into controlled factory environments, China has drastically reduced construction time, cut costs, and minimized waste. The speed and efficiency of modular construction are exemplified by the time-lapse footage of these towering structures rising almost overnight. What once seemed impossible, the creation of massive skyscrapers in a matter of days, has become a tangible reality, thanks to the precision and coordination of modular techniques. Every piece of the structure, from walls and floors to plumbing and wiring, is pre-assembled and tested in factories, ensuring that the on-site construction process is streamlined and free from delays typically caused by weather, labor shortages, or supply chain disruptions. This method not only speeds up the construction timeline, but also ensures higher quality control as the prefabricated components undergo rigorous testing before reaching the site. Modular construction also offers additional advantages that traditional methods simply cannot match. One of the most critical benefits is increased earthquake resistance. By utilizing modular units that interlock and are designed to absorb and distribute seismic forces, buildings constructed using this method are more resilient in areas prone to earthquakes. This added stability is particularly important in regions like China, where natural disasters are a constant threat. The ability to create structures that are both strong and fast to build represents a major advancement in ensuring that urban growth does not come at the cost of safety or sustainability. In addition to reshaping the way cities are built in China, the country's modular construction revolution is set to have a profound impact on the global building market. With urbanization on the rise worldwide and the demand for rapid construction solutions intensifying, modular construction offers a faster, more cost-effective alternative to traditional building methods. As cities around the globe grapple with challenges like population growth, limited space, and the need for more sustainable infrastructure, this technique provides an answer that can meet these demands while reducing construction waste and energy consumption. The advantages of modular construction go beyond speed and cost. By using prefabricated materials, the method allows for better use of resources, reducing the carbon footprint of construction projects. Since much of the construction work is done in a controlled factory environment, the process minimizes waste produced on-site and lowers the environmental impact associated with traditional building methods. As sustainability becomes a growing concern globally, China's adoption of modular construction could lead to a major shift in how buildings are designed and constructed, offering a more eco-friendly solution to the challenges of modern urbanization. As urban landscapes evolve and the demand for rapid construction intensifies, the widespread adoption of modular construction seems not only inevitable, but essential. The ability to build tall, strong, and sustainable buildings quickly and efficiently will become increasingly important as the world's cities continue to expand. With China leading the charge, it is only a matter of time before modular construction techniques are adopted globally, revolutionizing the way we think about urban development and reshaping skylines worldwide. The future of city building is already here, and it's modular. Tunneling titans, TBMs that dig cities under cities. Beneath the surface of China's most populous cities, tunnel boring machines, TBMs, are carving out subways, highways, and critical infrastructure at an unprecedented rate. These colossal machines, some of which are the size of entire buildings, have transformed the way urban spaces are developed. They are capable of digging through solid rock and soil with remarkable precision, creating vast underground networks that support the growing demands of megacities. One of the standout examples of this technological marvel is the Jiaolong, a TBM used in the South to North Water Diversion Project, one of the most ambitious and largest earthworks on the planet. The sheer scale of these projects highlights China's commitment to developing infrastructure that can sustain its rapid urbanization and improve quality of life for millions of people. The Jiaolong and similar TBMs use advanced precision-driven technology to carve tunnels through complex geological formations, ensuring both speed and safety. These machines are equipped with cutting-edge navigation systems that guide them with sub-millimeter accuracy, allowing for tunnels that are not only efficient, but also safe for future use. The ability of TBMs to work through difficult terrain, including mountains and soft ground, gives them a distinct advantage over traditional tunneling methods, which often rely on explosive blasting techniques. By replacing the need for blasting, TBMs significantly reduce the risk of accidents and minimize environmental damage, such as dust, vibrations, and the release of harmful gases into the air. Beyond their safety and environmental benefits, TBMs are enabling a revolutionary shift in urban development. As cities continue to grow in both size and population, there is an increasing need to expand infrastructure without further congesting the already limited surface space. Traditional methods of building roads and railways require significant disruption to existing buildings, businesses, and roads, often resulting in costly delays and widespread public dissatisfaction. TBMs, on the other hand, allow for the creation of underground infrastructure, subways, water tunnels, utility conduits, without impacting the surface level of the city. This means that urban spaces can grow both vertically and horizontally, with new facilities and services being added beneath the ground, leaving the above-ground space free for other developments. The role of TBMs is becoming ever more critical as China continues to invest in extensive subterranean networks to support its burgeoning urban populations. From the rapid expansion of subway systems in major cities like Beijing and Shanghai to the development of new water systems and underground highways, TBMs are facilitating the infrastructure that is needed to support millions of people. These machines are making it possible to dig through mountains, underwater landscapes, and dense city grids, once thought impossible, turning complex engineering challenges into achievable projects. This underground revolution is not just changing the way cities are constructed, but is also enhancing the functionality of urban spaces. With underground tunnels, cities are able to establish faster transportation systems, such as subways that connect neighborhoods that were previously isolated by geography or congestion. Moreover, by shifting utilities like water pipes and sewage systems below the ground, TBMs help keep cities more organized and less prone to issues like flooding or utility failures that can disrupt daily life. As China continues to advance its tunneling technologies and expand its subterranean infrastructure, the role of TBMs will only grow more vital. These massive machines, capable of digging through rock and dirt with surgical precision, have already achieved what was once considered impossible in urban planning. They are not just tools for building tunnels. They are transforming entire cities, creating new spaces, and laying the groundwork for smarter, more sustainable urban environments. As the technology behind TBMs continues to evolve, it will open up new possibilities for infrastructure projects across the world, pushing the boundaries of what can be accomplished underground and offering a blueprint for cities of the future. AI and robots take over the construction site. In an era of increasing automation, China is leading the way with the integration of AI and robots on construction sites. Autonomous cranes, excavators, and bricklaying robots are no longer science fiction. They are operational realities in China's fast-paced construction industry. These machines operate with pinpoint accuracy and without the human errors that traditionally slowed down projects. Real-time analytics, powered by AI, allow machines to make decisions on site, optimizing construction progress based on the most current data. By reducing human intervention, the risk of labor-related accidents is minimized and precision is maximized. This automation is particularly crucial in high-risk environments, such as tall buildings or hazardous sites. The seamless interaction between AI and robotics in construction sites and also allows for the creation of intelligent infrastructures, where sensors and data networks monitor everything from building materials to structural integrity in real time. China's digitized construction model could serve as a blueprint for the rest of the world, with the potential to transform not only the construction industry, but also the very fabric of modern cities. Electric and eco-friendly green machines. Changing the game as China aggressively works toward its carbon-neutral goals, the construction sector has seen a shift toward electric and eco-friendly machinery. Electric excavators, loaders, and other heavy-duty construction vehicles are becoming the new standard, replacing their diesel counterparts in urban areas. These green machines reduce noise pollution and lower emissions, making them ideal for construction in densely populated areas. One notable advancement is the use of new battery technology that has allowed electric machines to match or even surpass the power of traditional diesel-powered vehicles. Pilot projects in urban zones have already deployed entire fleets of electric machines, demonstrating their effectiveness and cost savings. This shift towards greener construction practices is part of China's broader environmental strategy, and sets a global example of how large-scale industries can adopt sustainability without sacrificing productivity. As other nations race to meet their own carbon goals, China's experience with green construction machines may serve as a critical lesson in achieving eco-friendly urban development. Unmanned highways, how 158 kilometers was paved without a human driver. In a striking example of automation, China recently completed 158 kilometers of highway resurfacing using driverless pavers and rollers. Coordinated by satellites, AI, and 5G, these unmanned machines achieved unprecedented accuracy down to the centimeter. The completion of this highway project without human drivers highlights not only the immense potential of autonomous construction, but also the major implications for road safety and efficiency. With these unmanned machines, construction projects can be completed round the clock, with no downtime for drivers, and with significantly fewer labor hours. The precision involved reduces human error, leading to smoother, safer roads. As AI, 5G, and satellite technology converge in this new model of highway construction, the implications extend far beyond cost-cutting. The development of unmanned highways could become the global standard for future roadworks, pushing the boundaries of what's possible in infrastructure development. This kind of automated construction may soon become commonplace across the world as the industry embraces efficiency, safety, and 24/7 productivity. 3D printing the future. Structures that rise overnight. China has taken a giant leap in construction technology with the advent of 3D printing. This innovation allows entire buildings to be printed layer by layer in a matter of days, often just 24 to 48 hours. Using materials like quickset concrete and recycled construction waste, 3D printing not only accelerates construction, but also offers significant cost savings, up to 70% compared to traditional building methods. The potential applications of 3D printing in construction are vast, ranging from disaster relief housing to low-income dwellings in remote areas. This technology is particularly transformative in regions where speed and affordability are crucial. By bypassing the need for extensive labor and material sourcing, 3D printing reduces waste, making it an environmentally friendly solution for construction. The structures themselves can be customized with unique designs and optimized for energy efficiency, meeting specific local needs. As China leads the charge in this technological revolution, it is set to inspire a global shift in how we think about building cities. With the ability to print entire homes and offices in mere days, 3D printing offers the possibility of creating buildings that are not only faster to construct, but also more sustainable and affordable. This shift could make a profound impact in rapidly urbanizing regions around the world, where traditional construction methods are often too slow or costly to keep pace with demand. China's embrace of 3D printing marks a new era in construction, where innovation, speed, and sustainability are at the forefront of building the cities of tomorrow. High-speed rail tech, building tracks at lightning speed. China's progress in high-speed rail construction is nothing short of revolutionary. With custom-built machines designed to lay down 1.5 kilometers of rail per day, the country has created the world's largest high-speed rail network. This incredible feat is made possible by innovations in construction technology, including specialized rail-laying machines that allow for faster, more efficient construction. China's rail technology has proven essential for expanding its domestic rail system, connecting cities that were once far apart and reducing travel times across the country. The ability to build tracks over diverse terrains, wetlands, mountains, and deserts, has unlocked new possibilities for infrastructure development, making it easier to integrate remote regions into the broader economic system. This high-speed rail network is not just a national asset, but also an export success, with China offering its advanced rail technology to countries around the world. By taking advantage of modular construction techniques and precision-driven machinery, China has redefined what's possible in rail infrastructure. The speed and efficiency with which these projects are completed are paving the way for a future where high-speed trains can become a common mode of transport across continents. As China continues to push the boundaries of rail construction, the rest of the world is paying close attention, considering whether they can replicate such a model of speed and efficiency to meet growing transportation demands. China's mastery in high-speed rail construction is setting the stage for a transportation revolution where the movement of people and goods becomes faster, more accessible, and more sustainable. Megadams and water control, machines taming nature. China's engineering capabilities extend beyond city building and infrastructure. They also encompass monumental projects that tame the natural world itself. Among these is the construction of megadams, such as the Three Gorges Dam, the world's largest hydroelectric power station. The machinery used in these projects is equally impressive, capable of pouring thousands of tons of concrete with sub-millimeter precision. These advanced machines are essential in managing the massive scale and complexity of such projects. The Three Gorges Dam, for instance, serves as a symbol of China's ability to harness nature's forces to meet the energy needs of a nation. However, these projects are not without their challenges. Monitoring systems, advanced sensors, and real-time data analytics help predict and mitigate risks, such as landslides and seismic activity, ensuring the safety and longevity of these structures. While the construction of megadams provides crucial benefits like hydroelectric power generation and flood control, it also raises concerns about environmental impacts and the displacement of local communities. Despite these challenges, China's ability to complete these projects with such precision and efficiency has solidified its position as a leader in large-scale infrastructure. These technological advancements are setting the stage for a future where such mega projects become essential for managing the world's water resources, balancing energy demands, and protecting against the impacts of climate change. As China continues to dominate the field of large-scale engineering, the world is watching, considering how it might adapt similar technologies to meet its own challenges. Smart cities start with smart machines. The concept of smart cities is no longer a futuristic dream. It is becoming a reality, and China is at the forefront of this transformation. In places like the Shang'an area, a city being built from scratch with AI and advanced construction tools, China is laying the groundwork for the cities of the future. The machines used in the construction of these smart cities are not just tools. They are interconnected with city planning platforms powered by AI. Roads, pipes, energy grids, and even buildings are being constructed with sensors embedded within them from the very beginning. These sensors collect data on everything from traffic patterns to energy usage, feeding real-time analytics back into the city's AI systems, which in turn optimize the infrastructure on the fly. This seamless integration of technology into the construction process ensures that every aspect of a smart city is built with efficiency, sustainability, and convenience in mind. In a smart city, the infrastructure not only serves its basic functions, but also interacts with the population to provide better living conditions. China's approach to building these cities is transforming the way we think about urbanization, offering a glimpse into the future where every building, road, and utility is interconnected and optimized for a sustainable, efficient, and livable environment. As the world's population continues to migrate to urban centers, the smart city model provides a potential solution for managing this growth in a way that balances technology, sustainability, and human need. What China still has to overcome. Despite China's remarkable success in transforming its construction capabilities, there are still significant challenges to overcome. One of the most pressing concerns is the balance between speed and quality. As China continues to push the boundaries of what's possible in construction, there are growing worries about whether this rapid pace of development might compromise the long-term durability and safety of some projects. In a race to build faster, there's the risk of cutting corners in areas such as materials, quality control, and labor practices. Another challenge is the displacement of traditional workers as automation and robotics take over many aspects of the construction process. While these machines increase efficiency and reduce labor costs, they also pose the question of where the displaced workforce will go and how China will manage the social and economic consequences of this shift. Additionally, the environmental impact of megaprojects remains a concern, especially when it comes to large-scale land development and resource extraction. While many of these construction techniques aim to be more eco-friendly, the rapid pace of development often brings with it significant ecological trade-offs. Lastly, there's the issue of geopolitical tension. The incredible efficiency of China's construction machines has raised eyebrows on the global stage, with some nations viewing these technologies as potential tools of influence and soft power. As China continues to expand its reach, these challenges, both internal and external, will play a crucial role in determining whether the country can maintain its position as the leader in global construction. A glimpse at the future of global construction. China's rise as the world's fastest builder is a testament to its ability to harness cutting-edge technology, drive innovation, and scale its engineering efforts to unprecedented heights. The machines behind this transformation, whether it's the self-driving bridge beasts or the 3D printers capable of constructing homes in mere days, are not just tools for faster construction. They represent a new era in how we build our world. China's infrastructure projects, powered by these machines, are redefining what's possible in the construction industry, setting new standards for speed, efficiency, and sustainability. As these technologies continue to evolve, they are not only reshaping China's urban landscape, but also influencing global construction trends, with other nations eager to adopt and adapt these innovations. The implications of this shift are far-reaching. It could change how we approach urbanization, sustainability, and economic development on a global scale. As China leads the charge in building the cities of the future, the rest of the world must decide whether to follow in its footsteps or risk being left behind. What's clear is that construction is no longer just about bricks and mortar. It's about the machines that make it all possible, and the countries that can master their power will define the future.